In this video, we will learn how to solve trigonometric equations. First, we will go through the rules to solve trigonometric equations before we attempt more complicated examples. Finally, we will learn how to solve for the general solution of trigonometric equations. So, what are the rules to solve trigonometric equations? We will go through these rules as we attempt this example, as this is the best way to learn. In this example, we are required to solve sine of 2x equals to negative half, where x is between 0 and 2 pi. Step 1. Find the base angle. What is the base angle, you may ask? The base angle is essentially the first quadrant angle which gives you the positive trigonometric value. For this case, we have a value of negative half here, so the question is, what angle for sine in the first quadrant would give you the positive value of half? If you refer to your table of basic trigonometric values, that angle should be pi on 6. So therefore, our base angle is pi on 6. Step 2. Find the angles in the relevant quadrants. The question is, what are the relevant quadrants? Again, since we are talking about a value of negative half here, we need to find the quadrants where signs are negative. If you look at the unit circle, you know that those quadrants are the third quadrant and the fourth quadrant. Therefore, we need to find the values of 2x where we have our third and fourth quadrant angles. For the third quadrant, remember that the third quadrant angle is defined as pi plus theta, so therefore, for this example, the third quadrant angle would be pi plus our base angle of pi on 6. For our fourth quadrant angle, remember the angle is 2 pi minus theta, so for this case, it would be 2 pi minus a base angle of pi on 6. We can rewrite pi as 6 pi on 6 and 2 pi as 12 pi on 6 to make simplification a bit more easy, so that we get a final answer of 7 pi on 6 and 11 pi on 6. Step 3. Look at the domain. We know the domain for this case is x between 0 and 2 pi. But what we need to do is to manipulate this domain so that we can find the values that 2x, which is the term within your sign, can take. How do we do that? We can multiply all sides of your domain by 2. And this would give us 2x being between 0 and 4 pi. What's the purpose of looking at the manipulated domain? By looking at this manipulated domain, we know that 2x can exist within the first two revolutions, with the first one between 0 and 2 pi, and the second one between 2 pi and 4 pi, which leads us to step 4. Find the angles in the other revolutions. From step 2, we've already figured out our two first revolution angles, which are 7 pi on 6 and 11 pi on 6. So how do we go on to the other revolution angles? By adding one revolution forwards. And remember, how much is one revolution? 2 pi. So essentially, we just need to add 2 pi to our two first revolution angles to get our other revolution angles. And this can be written as 12 pi on 6, which simplifies into 19 pi on 6 and 23 pi on 6. Finally, step 5. Solve for x by multiplying both sides by half, and this should give you x equals to 7 pi on 12, 11 pi on 12, 19 pi on 12, and 23 pi on 12. All your solutions should be within the given domain. And that's it. Let's go through a second example so that we can reinforce the 5 steps I have told you in the previous example. In this example, we are required to solve 2 times cos of x on 2 minus 1 equals to 0, where x is between 0 and 12 pi. First, we need to rearrange the equation to make cos of x on 2 the subject. To do so is fairly straightforward. We need to just add 1 to both sides so that we get 2 cos of x on 2 equals to 1, and then divide both sides by 2 so that we get cos of x on 2 equals to half. It is that simple. Hopefully at this stage, you have a rough idea of what the remaining steps are to solve for x, as they are pretty much the same as in the previous example. Why don't you pause this video now and have a try? Let's assume we've completed the entire question and solved for the final solution of x. We are going to go through the solutions together anyway. Remember, the first step is to find the base angle, and since we're dealing with the positive value of half here, The base angle for cosine, which gives you half, is pi on 3. Therefore, our base angle is pi on 3. Next, we need to find the relevant quadrants. What do you mean by the relevant quadrants here? Since we are dealing with the positive value of half, we need to find the quadrants where cosine are positive. This includes the first quadrant, which will give you the first quadrant angle of pi on 3, which is just our base angle, and the fourth quadrant, which will give you the angle of 2 pi minus our base angle of pi on 3. This will simplify into pi on 3 and 5 pi on 3. Next, you need to have a look at the domain, which is x between 0 and 12 pi. We need to manipulate this domain so that it contains the x on 2 within your cosine. To do that, we need to divide both sides of the domain by 2, which gives us x on 2 between 0 and 6 pi. Looking at this manipulated domain, we can see we are dealing with the first 3 revolutions, from 0 to 2 pi, 2 pi to 4 pi, and 4 pi to 6 pi. So, here are the first revolution angles that we've solved for in the previous step. We need to find the angles in the second revolution, and to do that, we need to add 2 pi or 1 revolution forward. We also need to find the angles in the third revolution, and to do that, we need to add 4 pi or 2 revolution to your first revolution angles. And this is what it simplifies into. Finally, multiply both sides by 2 to solve for x, and here are the solutions that you should get. Let's hope that you've got it right.